Okay, so let's start today our next topic. Well, today we will continue with the next problem following the theoretical part in previous class, right? So we have already discussed this resultant stress when a column of rectangular section is subjected to an eccentric load. Now let's solve some problem. So let's just expand this. See what the question here, it has been said. A rectangular column of width 200 millimeter and of thickness 150 millimeter carries a point load of 240 kilonewton at an eccentricity of 10 millimeter as shown in this figure. Determine the maximum and minimum stresses on the section. Well, see, this is a column, okay? Suppose you are standing here and this is a column, and if you want to see from the top, that top section of this column is this. So the dimensions are provided, followed by this question given in the question, which is 200 millimeter and 150 millimeter. So now in this column, as you can see, the force has been applied in a eccentric way. Mean from the center of the column, this force has been applied having some distance. So that distance is given here as 10 millimeter. So from the center 10 millimeter far, this load is applied. So what will be the maximum and minimum stress due to this eccentric load and due to this shape of the column? Let's just get into the problem. So here B, breadth, depth is given. So we can calculate the area, which is B into D. Now the load is given as 240 kilonewton, which can be converted into Newton. And the eccentricity is given. Now from our previous lecture, as discussed in the previous video, the maximum stress formula is load by area into 1 plus 6 into eccentricity divided by B, the breadth of the column, this one. Mean the dimension over which the force has been applied perpendicularly. Okay, so now put all the values as given in the question. P is 24,24,0000 Newton divided by our area, which has been calculated here, 1 plus 6 into eccentricity is 10 millimeter and our breadth is 200 millimeter. So this is our what? Maximum or minimum? This is our maximum because this is our positive sign, and the minimum will be the same formula approach. This is in a negative sign. So this will be our 5.6 Newton per millimeter square. Mean if you can calculate the total stress is basically 10.4 plus 5.6, basically it's a 16 Newton per millimeter square. This is the actual total stress coming onto the column. Okay, so the maximum one should lie upon here. Why? Because the stress is slightly inclined in this zone of the axis. So the maximum stress will be taken by this side of the column and the minimum one will be taken by this side of the column, as by common sense we can see here, isn't it? So this is a simple problem, numerical problem we can just check for. So extension of this problem here, another problem approach has been given, is what if we assume that what if say this side of the column we will consider, or we say as an engineer I am asking you to put that part of the column to be zero stress, minimum stress to be zero, and I want this side to be side of the column to be taken as the maximum stress. Mean this side of the column will take the maximum stress and this side will take only zero stress. So to make this kind of condition or scenario, what is our what thing could be variable? What thing could be variable? Well, dimensions can be changed. If we want to make this side of the column maximum stress and this to be minimum as zero, so what are the variation as an engineer you can change? So the dimension or the eccentricity, mean the position of the load we can change here, right? So here in this question, the similar approach what I have described just now has been given. In the problem 9.1, the minimum stress on the section is given 0. Then find the eccentricity of the point load of 240 kN acting on the rectangular column. Also calculate the corresponding maximum stress. So these are the following data given. Let's come into this place. So we want this side of the column to be felt the maximum stress, which is 16, right? If we would have add this value, we would get 16 and this one would be 0. So if you put the value here, see, just in the place of sigma minimum, to get the value of eccentricity, just put the value here 0, because here the known factor is sigma minimum 0 and the other data are given where we have to know the eccentricity. So by putting all the value, here we can see for 200 millimeter side, for 200 millimeter here breadth, if the eccentricity from the center is 33.33 millimeter, then we can achieve zero minimum stress at this point. Okay, as an engineer, there can be any kind of change you have to make. So you have to prepare yourself. You have to be prepared all the time. What are the variable we can change to manage any critical situation, right? So in order to get this side of the column minimum stress as to be 0, we have to change the position of our force 240 kilonewton in 33.33 millimeter distance. See, by putting the total value, if you put the value, we will get 16 Newton per millimeter square. So this is a very simple problem. Please go through this problem. Thank you for watching this video. If you have any question regarding this, you can comment me in the section box.